Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We shall start our tutorial class by now. Okay, I would like to discuss with you some of tutorial questions. Okay, so we start with number 1, question number 1B. Question number 1A is about Gauss-Jordan elimination method. So we have not learned that yet. So we move to next question, 1B. Okay, 1B, to consider the following system of linear equations. Alright, determine the value of H for which the given system has no solution. So you want to find the value of H so that the system has no solution. So here is the step. Alright, firstly you have to transform the given system into augmented matrix. So next, I hope you have no problem to transform into augmented matrix. So that left part is the coefficient of the system and the right part is the constant. Okay? So and then next step is to find, to determine the leading one. Is there any leading one for row 1? Yes, we got here leading one. So then next is you have to zeroize the number below 1. So to zeroize the number below 1, okay, remember elementary row operations, right? There are 3 operations. 1, okay, what is the 3 operations? Number 1, the arrow. What is the elementary row operations? 1, change row, right? Ri change to Rj. Operation 2, multiply with a scalar, isn't it? And then changes to row j. And then number 3, addition, right? Kri plus Rj changes in Rj. So these are 3 elementary row operations. Alright. So to zeroize number 2 and negative 1. So perform, you should apply this one. So this formula you should create, right? Negative 2 multiply R1. So the scalar negative 2 you multiply with R1. Why? Because R1 is a leading one, has leading one. So you should multiply the scalar with a leading one. Row that has leading one. And then plus R2. Here the changes in R2. Okay, plus R2. So changes in R2. So all the entries here, you should apply this formula, right? The first formula. Okay, so there are changes in entries. So next one, negative 1, to zeroize by applying this formula, R1 plus R3. Okay, so R1 is leading one, R1 plus R3. So you got here 0, so the rest also apply this formula. Okay, here is the new augmented matrix. So next one, row 2, yes, we have here leading 1. So you have to zeroize number 3 by applying this formula, negative 3 R2. Negative 3 multiply with a row that has a leading 1, which is R2, plus R3 changes in R3. So this is the final row echelon form, or sometimes we call it row echelon matrix. So we are ready to find the value of H so that the system has no solution. So for the system has no solution, this part, the left part must equals to 0 and the right part must not equals to 0. This is the condition for the system has no solution. So you should understand this. Okay. So H squared minus 4 equals to 0. Okay, you solve this H, you get 2 and negative 2. And H minus 2 not equals to 0, therefore H not equals to 2. So, right, you compare this one, compare these two answer, you will get H equals to negative 2. Alright, you proceed to next question. Question number 2 also the same, right? Not really the same, but this one you have to Question 2 is to solve the system of linear equation by using Gaussian elimination method. So for Gaussian elimination method, remember the step 1 to get a ref. I get a row echelon form matrix, a row echelon matrix or row echelon form. Number 2, by using back substitution. Okay. So first, get the ref. So how to get the ref? You have to write the augmented matrix, reduce the augmented matrix by using elementary row operations, and then you will get this answer. So based on this one, right, observe that the first and the second column, they are called pivot. Why pivot? Because has leading 1 respectively. Then, but the third column, which represent Z, this one non-pivot, so Z will hold free variable. Therefore, you should assign Z to a parameter. Any parameter here, I assign T. So that T is an any real number. Then using a back substitution, you write this system, right? To this matrix, augmented matrix, to a system of linear equation. X plus y plus 2z equals to 4. Right? You just follow this, and then y equals to 3. Z equals to t. We have assigned this. So after that, you can solve for x by back substitution. You substitute y and z into this equation. You will get the final answer for x, which is 1 minus 2t. So this system has many solutions because have free variable. Right, next one, question 2b. To find the value of m so that the system has a unique solution and infinitely many solutions. Before you answer these two questions, firstly you have to get the ref. Transform the given system into augmented matrix, apply elementary row operation, alright, until you get this ref. And then look at the condition for unique solution. Left part must not equals to 0 and right part is any real number. And then you solve this, you will get this answer. Alright, infinitely many solution, both equals to 0. Solve that, you will get m equals to 2 and negative 2. Is that okay? I hope you will understand the working. Okay, we shall move to question number 3a, right? The given system. Okay, to find a unique solution and infinitely many solution. Again, we do the same process, right? Write the system into augmented matrix and then using apply the elementary row operation to get ref. After that, okay, using the condition for a unique solution. Left part is not equals to 0 and right is here. Left part not equal to 0, right part is any real number. So you solve this, n not equals to 20 over 8 and m any real number. So infinitely many solution, the conditions is both equals to 0. So n equals to 20 over 8, m equals to 58 over 8. So I hope that one is okay with you. Next question 4a. Okay, this also similar process, right? We transform the given system into augmented matrix and then you reduce it using elementary row operation, right? And to get ref. So question 1, to find the value of alpha so that the system has a unique solution. So you just want alpha. So we focus on left part. Is not equal to 0, therefore alpha not equals to 2. And question 2, to find the possible values of alpha and beta so that the system is inconsistent. So inconsistent here meaning no solution. So for no solution, the left part equals to 0, the right part not equals to 0. So solve that, you will get the value of alpha and beta. Okay, next question. This one will be final question that I would like to discuss in tutorial class. So firstly, you transform the given system into augmented matrix. This is called augmented matrix. And then using elementary row operation, you can reduce the augmented matrix to row echelon form. Then go back to this question, a unique solution. The condition is left part not equal to 0, right part any real number. Number 2, infinite many solution, both equals to 0. Then you solve that, you will get the value of k and m. And lastly, no solution. So for no solution, left part equal to 0, right part not equals to 0. So these the conditions for all this question, unique solution, infinite many solution, and no solution, you have to familiarize. You have to familiar all the conditions so that then you can answer the question. Okay, so I hope you will understand how it works. Okay, we have learned how to transform the system from augmented matrix. You should know how to transform that. Okay, and then you should know how to apply the elementary row operation to get a row echelon matrix. So, and then by using Gaussian elimination method, right, how to solve the system, right? There are 2 steps. First, get ref, and then secondly, apply the back substitution, right? You should do back substitution so that you can solve the solution. You can solve the system, right, to get the solution. So if you have any question, you can WhatsApp me, alright, or we can discuss in other class. Okay, so for that I end my class, my discussion with Assalamualaikum warahmatullahi wabarakatuh.